Bum 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 bum. Set an 8:15 alarm. Okay, good morning, everyone. I'm Alex, and this is another day of the Handmade Game Dev stream, day 33. And if you'd like to join me for this morning's wonderful coding content, all you need for that is your preferred drink. Mine is matcha. We've got matcha from a new supplier today. It's like a little cute matcha store in my hometown. Yeah, and usually their stuff is pretty good, so I'm optimistic, and I'm gonna have my sip. You should have yours too. No pressure or anything. Like it's totally fine if you don't. But I'm just saying, you'll be missing out. You'll be like, oh, I have to wait until a whole nother day to have my sip at the beginning of the stream. It's kind of like one of those FOMO things. It's kind of like one of those things we're using to boost engagement. Anyway, so we're now a couple of days into fighting this problem, and if you're not familiar, I don't I don't blame you if you aren't. But what we're trying to do is decouple the physics of our game here from the actual rendering, so it's not tied to the frame rate. And this has been a big problem because for this type of game, because we are a physics game, we have a whole bunch of very complicated physics interactions that we want to do, that we want to have going on, that are really systematically driven. Okay, something may have changed something that broke the game. That's okay. And the behavior of those systems works differently depending on the refresh rate of our monitor. So that's a huge problem. It means like basically none of the game we can actually really tune correctly until we get this right. Or we have to lock ourselves at some really crappy tiny frame rate that we think we can hit on like the worst possible hardware that we expect to be running on. So that would be a massive massive like failure on my end to have to accept that. To have to lock us at like 30 FPS or something would be really just I think that would be pretty bad. So, we've been at it trying to get things working for this decoupling on Mac with the Metal Render API, and things are not working right now. But we've been having this problem where Metal kind of does not let us do the timing of the draw and render or physics calls exactly the way we want to do them. So we're ending up with this behavior where things are incredibly stuttery and crappy looking, and it's just not good. It's just not good. So I'm trying to get inspiration right now. I spent some time last night making the profiling a little bit better to understand the problem, and it is we're getting called our render loop, our outer render loop is just getting called too many times, and we're not accumulating any time for the physics to do anything, so we are drawing a bunch of frames with stale data. We still don't know why. We still don't know why, because I think we're never seeing a Metal report a frame rate higher than. Also, this was like some AI crap. I'm getting rid of that because it it didn't really do what we wanted. But our goal here was we want to have an uncapped FPS. We want the ability to run it at uncapped FPS because that's something like our end player would want to do. But we also want to be able to prove out and see, if we can get the physics working at something even higher than what we're expecting to be running at. So we're right now we've been running at around 180 on this display, and then when we started to uncap the refresh or the VSync, we started to see things like up in like the 290s for our like very basic scene, right? But we're also trying to run the physics at about 480 hertz, right? So at 480 FPS. So what that should kind of turn into is we are doing like 1.5 physics simulations per render frame, and it's not working again, which is kind of creeping me out. So we're doing something. I think we might be just having a bug where we're not building up enough time again to hit the render part and actually open the window. But we would expect to see 1.5 physics simulations per time we're trying to draw to the screen. But it appears that even though Metal thinks we're drawing at 300 FPS, it's actually asking and sending stuff over to the GPU to do to compute, like to try to draw a Metal layer way faster than that at like the nanosecond speed, like time domain, because this is just like a loop that is going as fast as possible, but I think we're trying to hit this condition here, this next drawable thing, and I think it's not working. Like I think it's not. We're like never hitting this no drawable. We're never bailing out, and so then this is just running so fast, and it's just going to be sending like total junk to the GPU, as well as like running way more garbage on here than it needs to be. Because the theory of this decoupled physics and rendering basically is that the rendering is way slower than the physics, and you can after you do render one frame, you can kind of catch up and do a bunch of physics simulations based on the amount of time that was in between render frames. That's the theory, and we're not seeing that right now. We're seeing like the totally opposite behavior, because I think this condition's like just not getting hit. So I'm looking in a couple places. I was looking here this morning at both the raylib and the SDL implementations of Metal, and actually it turns out raylib does not have an implementation of Metal, so that kind of stinks. It just uses SDL on the back end to do that, and I don't blame Ray for going that way, based on kind of how irritating it has been to get Metal to do the things you want it to do at this level. And I don't know, I have not built anything with SDL before. I've tried like here and there to work with it, and I've read through some of the docs and example codes and all this stuff. I've not tried to get a really performant physics and rendering solution out of SDL, and especially not out of the SDL Metal backend before. But I'm thinking of, if if there's anyone that has solved this problem here, it's got to be one of these guys, right? That has the code to do this, and also there's all these other things too with the way Metal is a little different from how we're exercising. We first started doing our rendering for the game, exercising D3D11, where you can draw, and I think you can do this in D3D as well. You can draw the same textured quad multiple times as a uniform, right? I think that's what I understand, or as the same instance of a thing. And there maybe that like allows the GPU to do some extra um, parallelizing and workload optimizing that we aren't doing right now. But we're not hitting the point where we're like not even close to hitting the point where we're actually worried about the GPU performance, right? In all of our profiling, we are generating frames on the GPU end at like 20 microseconds or something, which is way more than enough to keep up with to draw at like a pretty good frame rate for now, and be able to do our physics, right? And that's maybe the problem, is that we are running at this speed. So let's go find like a milliseconds. We because so like 20 microseconds. Yeah, let's go do femtoseconds. 20 microseconds, 0.02 milliseconds, right? But 200 is 0.2. And that is maybe actually how fast our while loop is running. So also, it's very possible that it's very possible that the next drawable being available is actually just true, right? And that would explain sort of the what we see in terms of the relation from the number of draw calls to the number of physics sim steps we're doing. But then, the confusing part, right, is that does not translate to the frame rate that we are, looking at, that we think we're looking at on the 0.2 milliseconds. We think that equates to like 5,000 FPS, right? Which is obviously not happening. It's not even close. Unless, we are actually hammering the GPU at 5,000 hertz, but then whatever magic like is going on else in the metal scheduling level here is kind of like down regulating us to something else. So like and that's the problem. I think here the problem with developing metal and Mac here has proved to be the same problem that Apple has with all of its products that it ships to and to like people who are power users that try to do things on them, is they kind of are a little too smart for people that actually know what they're doing, or they assume a little too much and they don't let you do the thing that you actually want to do, right? And it's just been very surprising to I mean, I guess not, everybody knows that is ingrained into the culture and of what Apple puts out in terms of like its consumer product space, right? And it's just been I don't know, it's a little sad that is the way that they treat developers too. And I guess it's true, like, hey, most developers are not doing this. Most developers don't need this level of functionality, performance, and care in like how they're physics and rendering is performing. And like there are things we could do to also not care. Again, we can always be locking the frame rate down at some lower, at like 60 FPS or something. But then, imagine that of like we are forced to, because this one platform does not give us the flexibility we need to give players on every single other platform a shittier play experience in order to keep the physics all working and feeling the same from platform to platform. And that is the failure that I will not accept here. Because that's just that's just like a non-acceptable quality degradation for me to like be doing this here, so there you go. There you go. And looking through, basically the thing we're trying to find here is like how we found a bunch of like the pipeline code here, but I think maybe we have not really found the timing, excuse me, or how like SDL is trying to schedule metal here. This kind of looks like what we would want. So maybe the issue is, if we think about it, what like you would, how I would design the API would basically be, and how I think, like, from what I understand, how I think the API works is, we set up like the render encoder here in this loop, in this pass. We pass in our vertex buffer into it. We set our shaders, the primitive type, and all this stuff, and then we when we end encoding, that's like the thing that actually sends it over the wire, I believe, right? Oh no, I think this commit must be sending it over the wire, right? And then you have like these two pieces here, which are like also should be like GPU instructions, I think, to actually go present the drawable. And then so maybe what we're doing is we're not waiting around for like the completed handler to confirm that we've actually completed drawing and doing all the things that we want to do. I think that's very possible, and that's kind of what we were just looking at in SDL here. Yeah, so when these guys submit to the GPU, they do the thing. They have. It looks like they're sending like three, a couple frames at a time, maybe. And then they're reallocating it for some to just keep it. Okay. But I don't think anywhere here are we seeing us just like wait around. I think this mutex here is just waiting around for for the actual submit and the cleanup to be done, I mean, it's not like I don't think we're just waiting around here for like the next drawable to be available, and that's sort of maybe what we're looking for is the next drawable. Well, we did determine like that is not, we're going so fast that we're never hitting that. But yeah, because the problem we had before when we were using the metal display link, and that was handling vsync, was we would get into there, and then like that being the calling function, limited our ability to like get into like our physics frames. But that's, I don't know, that's like closer to what we want. But also, we don't want to be forced to vsync. We do not want to be forced to vsync if we don't have to. It's a little irritating here, and there you go. So what is this metal fence? Is that like a real thing, or that's something they invented? I don't know what I expected. Okay, here we go. Orders memory operations between GPU passes. I mean, yeah, that does seem like... But this is kind of like on the GPU you're delaying stuff. We really want to be waiting on the CPU end, I think. But we'll keep that in mind. And now I'm not really just grepping around this because I kind of don't know what I'm looking for here. It's a little frustrating because on I think like on DirectX, basically this is not a problem. And we haven't tried yet, but people have been doing this on DirectX like for a while. Binding, blah blah. Yeah, all the binding we don't really care about. Pipeline stuff we also like don't really care about right now. Okay, here we go. Begin render pass. Yeah, this does not look like it's really timing it. That looks like just the thing that calls all the other stuff. Acquire command buffer. Yeah, and I think this might be just like SDL has their own, a bunch of stuff for their like multi-threading solution. So they have like their own pool of command buffers that are statically allocated, I would assume, doing all this stuff. And they are doing some fencing, right? And hey, we don't want to do that yet. We don't want to even try to multi-thread this because like this doesn't work single-threaded yet, you know. So the last thing we want to do is to add a crazy level of complication by multi-threading our procedure that like just does not fundamentally work yet, you know. So there you go. Yeah, and sorry if this stream once again couple days in a row I think have been a little lame here. But once we have this, like, that's gonna be pretty close, like that will be like one of like that's like the biggest thing left that we have to do here. That is just like a stupid technical issue to solve before like we really can go back to game design, which I know we've been saying that for a while, but this breaks the feel and an actual like ability for you to do specific things in the game so much that it's kind of not acceptable. It's just like not a acceptable solution, and so that is where we're at here. No, I mean, we've gone too far. This is all like creating the metal device and struct definitions and crap. Okay, so that was not it. This is gonna be the shader, and then what is this? This is like also some, I think maybe the shader in just like in bytes here or something. Okay, so that's unfortunate. And then this is because this is going to be like way too high level here of just like reading through SDL's abstraction on top of all of these different render APIs. And that kind of sucks. That does kind of suck. I mean, we can try just like use sleeping for more. So if we use sleep for like 5 milliseconds, in between frames here. And also it's not working again. It's not great. Shit. So where are we? We're like stuck in here somehow. I think we must be stuck in this accumulator loop right now. So accumulator, we've accumulated 13 milliseconds worth of time, which is in fact bigger than the physics sim step that we're targeting. So we of 2 milliseconds, right? The delta t was 1 millisecond from the last one. So, what? We would need to be able to handle 13 times a second here. Or 13 times. Yeah, this is like really not quite working here. Well, so now we are seeing like bigger blocks of sim steps per like render steps, because this is like render pipeline start, render pipeline end, render loop start. So we are seeing game loop start. We're seeing 1, 2, 3, 4, 5 physics sim steps here per render frame that we're doing. And here we're seeing, 1, 2, 3, 4, 5, 6. 1, 2, 3. Here, this is a whole lot of them. It's kind of crazy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 16, 17. So what is going on? Why are we stuck here, not able to see the window pop up? So I changed everything to milliseconds. I bumped down the max drawable count. Frick. I think it's that. Because I was a little suspicious of this dispatch async queue thing. So I do just have it. That's probably it. I think it may be because we're never hitting NS application main right now. So we can try that again. Yeah, that was it. Oh, there we go. Hey, look, that is pretty fast there. You know what? While we're here, let's fix this stupid bug where it's not terminating correctly. And Ted's code will have that. Yeah, that kind of may work. Okay, that works. That's good. Okay. So let's I think right now. Oh, look at that. The gravity is so high with like a 100 mass. Oh, that looks pretty smooth. Oh, damn, that looks pretty smooth. Look at that. Oh, that looks pretty good. Oh, okay. That's good. Cause that looks like about 300 FPS, right? Doesn't it? And all we did was just like add a sleep here. Which also, it's kind of not great. But it may be the only thing that is saving us here. Well, are we hitting no drawable cases now? Oh, look at this. Oh no, that's our terminate. That's okay. That's supposed to happen. Yeah, I mean, it may be a couple things. We possibly were dropping a bunch of time on the floor. I converted everything from seconds to milliseconds. So we were maybe dropping some time. Printing out this accumulator still doesn't fucking work. But that could just be like a Stack Overflow overwrite bug, because I know there are definitely some of those in our stringing right now, which is it's really irritating. But I mean, like, it looks like what we want it to look like, you know? It does look like it works. uh yeah, so our frame interval is sitting about there. So we should expect to actually see, like, on average 2 sim steps. 1, 2, 3. 1, 2. 1, 2, 3. Yeah. And then there's times like where the frame rate dips a little bit and you're gonna get a little bit more. Okay. I mean, again, it really sucks that what we had to do was just add a sleep there, but I'm kind of at a loss right now for what else we could do that actually will make a difference here. Lock. Because if we're not doing that, like, I think the problem may just be that we're just hammering the GPU link too hard. I don't know. I mean, this kind of works, but like the thing we don't know is well, okay. So what we can try is we can tune the boost down. So let's actually commit that before I forget. Okay. Okay, so what we can do is we have some pretty insane multipliers here. Okay, so those are still way too high. Times. Oh, that is still too high. And then, this is like the last 30%. So, yeah, and then we want that to fall from 3 to that. Okay. Oh, whoa. Oh, my movement speed is too high? or is it? Oh, you know what? Maybe the goal has too much mass now. Uh, hmm. Hmm. So look at that. That's just so. Why is that happening? It must just be because, like, we're applying our base movement speed impulse so much now that it's just too high. So that, I mean, this has solved our problem we had of, like, oh hey, look, I can kind of travel around the planet right now. That's cool. You know what? This is like maybe a this is maybe something to test here, right? Is we can do this right now of the physics. So the okay. So we may still have some problems, right? So the physics is allowing us to get away with this, which is interesting because if this interaction right here is pretty precise right now, because if the gravity, if we're applying gravity so much, it gets it, as well as the movement speed, that for like a frame you go into the planet, then you're going to be met with the normal and restitution force, right? Um, but we should also try to, so like basically the if there was still a display a frame rate dependency on the physics, I would expect that to not work. I think that is like so tight to be able to do that. I think it should not work. Um, let's see. So I degraded that by factor. Okay, so we can kind of like bunny hop right now. And we're kind of skating. Oh, what may also have happened is our like coefficient of friction now behaves a little differently. It behaves a little differently with the different step sizes. Okay, but that all kind of makes sense. Okay, so we can bunny hop. We're just holding up, or just holding up. We're seeing like 5, 6 momentum. The bunny hop, you get up to like 200 maybe for like a frame. Straight up. And then you can ice skate, and you're sitting at around 35, 40. Okay, so those are all. Let's write that down. Let's write that down before we forget. B-hop. B-hop, like 250. Up 5. Skate 35. And yeah, we can do all of those things. Okay, yeah, I figured it out. So now if we were to increase this by So we're running at like around 200 FPS right now. So let's increase this to like 300 or something. Try to cut the FPS by some significant amount. Does not really look significant, does it? Did I build? It definitely still... It kind of still feels the same. Alright, let's increase that some more. We're still kind of doing all the same stuff. What is game mode, do you think? That, who knows? I also have never been able to figure out I have never been able to figure out how to just get this to not auto show up, because there are times where I don't want it to show up because it kind of irritates me. Game mode is on. Game mode is on, dog. Let's see. Frame interval histogram. It's a little interesting, I suppose. Missed 3 frames. And buffer encoder count. Yeah, those things are all pretty freaking fast right now. Game mode off. Yeah, it doesn't help anyway, so we want that. That. Yeah, this is the frame interval graph. Yeah, you want that. Enable performance insights. What is this? Is that gonna be some AI reading through my jank ass garbage here? Let's not. Okay, whatever. Okay, let's like bump this up. So that appears to be having like basically no effect on the frame rate we're running at here, right? Let's wait for 16 milliseconds. Oh, okay, there we go. Yeah, so you can bunny hop still. You can still do this. Yeah, but now we are running at like 35 FPS. But it still feels smooth. And yeah, you can do that. You can do that. And like, okay. You know, I think that actually may be... I think we may have gotten it. I think I am satisfied that is pretty frame rate independent there. Of at least all the things that we could kind of do at 200 FPS, we're doing at 35, and they kind of feel the same. It just, you know, looks shittier, right? Which is all what we expect. Oh, look at that. I found a problem. Okay, so we will have to recalibrate the we're gonna have to recalibrate the recharge time too, it looks like. Uh but cool. Damn, man, that like pretty much works. That pretty much does what we want it to do. Um yeah. I mean that yeah. And our memory usage went way down. That's a little weird. Um I don't know what would have touched that. Not quite sure. But yeah, super cool, man. You know, that's badass. Uh, that was a little interesting. So we bumped it up to there being a 16 millisecond sleep time. But that knocked us all the way down to like 40 FPS. Yeah, I mean, yeah, I don't know. I'm kind of are out of time to be able to do the math today. You know, we're gonna have to wrap up the stream here in just a couple minutes. But I think that's pretty good. I think that's pretty good. Okay. What do we do? Let's oops. Before we do that, let's go retune the recharge time. Because now clearly this is all like happening too fast. Oh, okay, that seems like, you know, at least we've gotten rid of the ability to just like infinitely boost boost faster than like, yeah, there's still like a little bit. You can kind of still do it. But you know, that is what we are actually going to be trying to work out when we're doing design, when we're doing a design stream, you know. Okay, well, cool beans. Yeah, let's commit that. Okay, well, that's awesome. That is, I was so worried that we were going to be continue to be stuck on that for a long freaking time here, and have some problems. And like, you know, again, I'm still not quite satisfied with this solution, because you know what it basically is going to mean is, I guess there's like a, well, all right, there's like a rolling 50 microsecond period in Mac, maybe only on the Mac, where you know, we're not able to get, we're not accepting like input from the player. Uh, and I think like 50 microseconds is pretty low. Keyboard latency. You know, keyboard latency is pretty low. Oh, whoops. Oops. Oh, I have to turn off Vimium for this website. Yep. Yeah. Yeah. So we're in the realm of like and it's fast. It looks like it's like faster when you're hot too, because maybe you're in the part of whoever's flow that knows, or maybe we just like warmed it up. I don't know. From cold. Okay, so but 50 microseconds is like this number right here, right? That's 50 microseconds. I think that's okay. I think that's acceptable because that's like kind of, I don't know. That does seem to be like within the error you could possibly expect. What would be good to see is like what is the minimum you could do if we do like 10 microseconds, because that would be really, I think that would really be negligible there. That's not good. Yeah, you know what? I think maybe we'll keep it there then. You know, and we're getting at crappier FPS because we're running the console right now. I think. Okay, so we do have Zen open here. Oh, okay, that was it. Yeah, I mean, I think I would prefer. I think let's try to keep it there, because the less just like garbage latency we add in here, the better. you know what I'm saying? Knocked down sleep. Oh, okay, whatever. But yeah, that's gonna be all for today. Thank you very much for watching. I'm pretty happy with where we got to today, even though if you were to look at the code change, it's a little lame. It's it's a little lame, but I mean it works. It seems to work right now, doing the things that we wanted to do on Metal. We're probably going to be staying on Mac and Metal for quite some time. But at some point, we will most likely be jumping back to Windows, doing stuff there, because honestly, the software development environment's a little bit more painful. Oh, yeah, Kille. I'm just wrapping up the stream. Good to see you, though. Thank you for tuning in. Hello. But also, goodbye. I've got to go run off to work now. Have a great rest of your day, and everybody, Anyone who's watching the VOD or anything, have a fantastic day, and keeping on programming. Keep on doing your stuff. Bye for now.